the remainder of the lesson. Okay, so in general, for y equals ax squared, first of all, if the absolute value is greater than 1. So in other words, when we're talking about absolute value, I don't care whether it's positive or negative. So if that number is greater than 1, the parabola undergoes a vertical stretch. So in other words, that's numbers like 2, -2, so as long as it's greater than 1. Okay? If the absolute value is less than 1, so in other words, it's a decimal, and if you notice, I don't include the 0 because that makes it a horizontal line, the parabola undergoes a vertical compression. Okay, and finally, if a is negative, so in other words, if it's less than 0, we know that the parabola is reflected down. Okay, so in other words, it opens down. So let's look at a couple different examples that we're going to be expected to do. Okay, so the first one, it says graph y equals x squared, then on the same axis, graph y equals 3x squared by comparing it to x squared. Okay, so what we could do is we're going to do, and then over 1, up 1, back to the vertex, over 2, up 2 squared, which is 4, over 3, up 3 squared, which would be 9. Okay, and then we know that we can then graph by the reflection on the other side. Okay, so there are the points for y equals x squared. Now to do it for 3x, I'm going to take all those values and multiply them by 3. So I'm going to change colors. So I'm going to multiply them by 3. So 1 times 3, 4 times 3. Okay, you can see it's 12. So it's already off my axes already. Okay, so that's what we end up having. So what we end up doing is, and if you notice, I have created it for you. Okay, so we've taken those points, and that's what we've done. Okay, now the same is going to be true for example number 2. Again, we're going to graph y equals x squared, and I will do it in blue. So over 1, up 1, over 2, up 4, over 3, up 9. So that step pattern I should have in my head all the time. Then I need to take a quarter of those values. So a quarter of 1. So again, I'm going to change it to quarter. Now it's a little bit harder to do, right? A quarter of the number 4 would be 1. Okay, and then a quarter of this 9 would be approximately 9 divided by 4, 2.25. Okay, so you can see that we end up having things that are much smaller. So it's taken those y values and has compressed them on us. Okay, so that when we go to graph them, you can see what happens if I get it to do it for me. Come on. Oops, didn't want it to do that. There we go. Okay, so it's not coming up. That's all right. We'll just then, oh, there it is. Okay, so it gives you an idea of what it looks like. So it is a flatter type of parabola. Now, the next type of question is a little bit different in the sense that we have the function y equals, it's supposed to be y equals ax squared, and I know that it passes through the point 4, 7. Okay, but I don't know the value of a. So if it's in the form y equals x squared, it means it still has a vertex at 0, 0. So what I can do is this 4 becomes the x value, so I'm going to substitute the 4 in for x, and the 7 is the y value. So I'm literally going to start with the equation y equals ax squared. I am going to substitute 7 in for the y. A stays the same, and for the x, I'm going to put in the 7. So that's going to be 7, sorry, it's going to be 4. It's going to be 4 squared. So what I end up having here, well, 4 squared is 16. So I really have on the right-hand side 16a, and on the left side I have 7. So to isolate a by itself, what I end up having is dividing both sides by 16, so I end up with 7/16 equals a. Okay, so what we do is I sub the point in for x and then solve for a. It's that simple. Now, it asks for what is the value of a, which we have found, but if it asks us what is the equation, the parabola has the equation y equals 7/16 x squared. So it's really not that difficult. It's just remembering when to do that. Okay, the last question. So let's take a look at this one. On Earth, the vertical distance fallen by an object in free fall is given by dt, okay, there's our function notation, equals 4.9 t squared, where t is the time in seconds since the object was dropped and the distance is given in meters. Okay, so it asks how far would an object fall in 4 seconds? Okay, well, t is our time in seconds. It does tell us that. So we're really finding d of 4. So we're going to start with that, and we're going to have d of 4 equals 4.9 times 4 squared. When I do that again, 4 squared is 16. And multiply that by 4.9, and I end up with 78.4 meters. Okay, so it's just a matter of substituting it in. So here's a really good example of function notation in a real situation. Now, it is 335 meters to the sky pod. Okay, that's the first viewing deck on the CN Tower in Toronto. If you were standing below and saw a small chunk of ice fall from the bottom of the sky pod, how much time do you have to get out of the way? So this time what we have is we have the value for d of t, but I don't know what t is. Okay, so I know the value of my function needs to be 335 meters, but I need to find t. So all we're doing is we're substituting that into our equation. So 335 equals the 4.9 t squared. Okay, so again, I'm isolating for t. So the first thing I'm going to do is divide both sides by 4.9. When we do that, we end up with approximately 68.36. Okay, so I'm keeping quite a few decimals. Equals, and that is our t squared. Now to find t, we have to take the square root of both sides. Now remember, when we take the square root of both sides, there's a positive and a negative number. Now think about this. We don't want negative time. We only want the positive value. So when I take it, it's approximately equal to 8.3 seconds. So in conclusion, I would have to put you have 8.3 seconds to get out of the way, or that ice is going to come down on you. Okay, so a few questions for you to work on. Have some mathematical pleasure in your life.